Hello, this is Math 275, Differential Equations at Cañada College. My name is Lapuz, and we are doing a problem from section 2.3. They want us to consider the initial value problem, y prime is equal to e to the x times y equals f of x, with the initial condition y of 0 is equal to 1. And they want us to find our solution for the initial value problem is a non-elementary integral when f of x is equal to 1. All right, let's begin by writing down our differential equation when f of x is equal to 1. So let's put a 1 in for f of x, and we see that this is a linear, first order linear differential equation. Then we will find the integrating factor. So the integrating factor is going to be e to the integral of p of x, and p of x is just e to the x. And so the integral of e to the x is e to the x, so this is e to the x, and that is your integrating factor. Now we're going to multiply everything by this integrating factor, and the algorithm basically tells us that when we do so, our right-hand side is going to be a perfect product rule. And so we can just take the antiderivative of that to get the actual product. And so this is going to be d dx of e to the x, which was mu times y. And this is e to the x on the right-hand side multiplied by 1. Okay, we will integrate both sides. And the left-hand side will be the undoing of the derivative. So we just have e to the x times y. And now the right-hand side is unknown. I don't know this integral. And so we're just going to have to write it as a non-elementary integral, which is what they were asking for. So this is the integral. And let's, we want the x as the variable, and we're going for x bigger than 0. So let's start from 0 to some x. And then now we have to change the dummy variable here. Let's just use dt. And then when we do that, we're going to get an extra constant that pops out. Okay. Now, the initial condition says that we want x to be equal to 0, and when x is equal to 0, y is equal to 1. So let's go ahead and put the zeros in for all the x's. And we're going to get e to the 0 is 1 times e times 1 is e. And this whole expression, the integral from 0 to 0, is going to give us a 0 because there's no area to look for. And then so c is equal to e. And I have, we can solve for y. And this would be e to the negative e to the x power. We have the integral from 0 to x of e to the t dt, and plus our constant e. So those are essentially the things that would go in your problem here. This is e, not just a constant, arbitrary constant c, but we actually found it to be e. Okay, that is our first part of the problem. Now let's jump to our second part of the problem, where we're asked to find the same differential equation and initial condition, but this time f of x is going to be equal to 0. So let's rewrite the original problem, or the problem that's been redone. We have y prime plus e to the x times y is equal to, this time it's 0. And we'll use the initial conditions a little bit later. We still have the same p, and so we're still going to have the same integrating factor. And we can actually jump down to here. d dx of e to the x times y is equal to, now we're going to multiply the integrating factor e to the x times 0, and that's still going to give us 0. Antiderivatives. We're going to get a constant on the right-hand side, and e to the x times y on the left-hand side, and then we put in the values for from the initial condition. E to the 0 times 1 is equal to c. E to the 0 is 1. E to the 1 is e times 1 is e, so c is equal to e again. And if I take it from here and solve for y, I'm going to get e to the negative e to the x times the c value that we found. And oops, the c value is actually e. And now we can type in our answer just like that, or we can combine using some properties of the exponent, 1 minus e to the x. So e to that power, e to the 1 minus e to the x would be our solution for the second one. Okay, now we have one more to do, and that last one to do is assuming that the right-hand side is equal to e to the x. So let's go ahead and do that. We will write our differential equation, y prime plus e to the x times y is equal to e to the x. And we have our initial condition, y of 0 is equal to 1. Okay, assuming we're starting from scratch. Well, let's not start from scratch because we know the integrating factor already. We know that the integrating factor is e to the x. And so we know that the right-hand side is going to be e to the x times y. And the left-hand side would be, so this is d dx, perfect product rule. This would be e to the x times e to the x. Now, this is the part where we integrate. And let's take this integral off to the side here. The integral of e to the x times e to the x dx. I think if I let u equal to e to the x, and du will be equal to e to the x dx. I have e to the x dx and e to the u, so it's just the integral of e to the u du. It's going to be e to the u, which is going to be e to the x. And let's throw in a plus c constant. So the left-hand side would undo the derivative, and the right-hand side would be e to the x plus a constant. All right, let's plug in our initial conditions. E to the 0 times 1 is equal to e to the 0 plus c. This is just going to be e is equal to e plus c, so c is equal to 0. And then c is equal to 0. So that means e to the x times y is equal to e to the x plus 0. Let's divide out and say y is just equal to 1. That's it. Y is equal to 1. Okay, so just mark our answer here, and that's the end of this problem. All right, I hope that helps, and good luck with your work.